Alrighty guys, so we're going to talk about how to solve heating curve problems. There are two types of calculations in heating curve problems. The first type of calculation is a Q equals MC delta T calculation, whereas in the second type of calculation it's a thermochemical or stoichiometry calculation. These stoichiometry calculations, of course, will take the grams, the number of grams from the question, over 1, times the molar mass, aka, I'm going to just write molar mass here, as a fraction, times the mole to energy relationship, aka the new relationship, as a fraction, times the, finally, kilojoules to joule relationship, with kilojoules being on bottom and joules being on top. This will equal our unknown number of joules. Here, of course, you plug in your mass, your specific heat, and your change in temperature. Sometimes you may have to do a secondary calculation for the change in temperature. Remember, change in temperature is equal to the final temperature minus the initial temperature. Okay, so we've got these two calculations, but we really need to read the question before we do any of these calculations and find out how many calculations we're going to do, what types, and where. So we're going to talk about that first. Let's read the question. What is the total energy required to raise the temperature of 135 grams of water from 22.0 degrees Celsius to 133 degrees Celsius? Please draw this change at all parts on the heating curve provided. So the first thing we want to do is we want to put the minimum temperature and the maximum temperature when we do not have any graph drawn. The minimum temperature was 22 degrees Celsius, and the maximum temperature was 133 degrees Celsius. Two phase changes occur for water. There is one at 0 degrees Celsius, this is the melting point, and there's one at 100 degrees Celsius, this is the boiling point. Now, between 22 and 133 degrees Celsius, there's not two phase changes, because 22 degrees Celsius to 133 degrees Celsius, well, this range of numbers here is already higher than 0 degrees Celsius. 0 degrees Celsius is somewhere under 22 degrees Celsius. 100 degrees Celsius, however, is in between them. It's not perfectly in between, but you don't have to make your graphs that perfect. This is just for the sake of drawing our graph. So since between 22 degrees Celsius and 133 degrees Celsius there's only one phase change, we're going to mark that phase change with a dashed line, and temperature changes will occur below that until it heats or reaches that phase change temperature. When it reaches that phase change temperature, it's going to start shifting. It's not going to change temperature. It's going to start shifting from the previous state to the next state. In this case, from liquid to gas or steam, with basically with the phase change at the this is actually the vaporization point. Also known as the boiling point. Okay, so what we do is we draw a line going up to 100 degrees Celsius, the first phase change, the only phase change for this calculation. We draw a straight line to show the phase change, so that once everything that is liquid is transferred into gas, temperature changes can begin again, and we slope to show that temperature change for the gas from 100 degrees Celsius to 133. Essentially what this is telling us is that we have one calculation, two calculation, and three calculations. In deciding what type of calculations occur at each one of these portions of the graph, the first, the second, and the third, we need to look at the shape of the line, or rather whether or not there's a slope or if there's no slope. If there's a slope, in that section of the graph, we will use Q equals MC delta T. If the line has no slope, aka it's flat, we use the stoichiometry calculation. The difference, or the real importance of the difference here, in slopes there's changes in temperature, like in this slope right here. A temperature change occurs from 22 degrees Celsius to 100 degrees Celsius. Where there's no slope, there's no change in temperature, so we cannot use Q equals MC delta T. Instead, we must use stoichiometry. Here, no change in temperature, since it's a flat line, so we'll have to use stoichiometry. So just to kind of clarify, slope on number 1, a slope on number 3, we're using Q equals MC delta T. Here and here. Here, because we have no slope, we're going to be using stoich. Okay, that should help you in terms of setting up your calculations. This is just the first part in the setup. See part 2 for how to do the actual calculations for the slope lines and for the flat lines. Thank you and have a great day.